That's cool. Perfect. Well, it's going to be a talk, to be honest, about Swarm quite a lot. The thing is that when I joined my current company, we were running like a big and quite ugly monolith written on PHP, and that was like that was 10 years ago it was written. And I was given a goal to generally deliver faster and safer. And well, we were facing a problem moving fast, even with that number of people we had. We planned having a lot more people, a lot more engineers, product owners, and we needed to go a lot faster than we were able to. Well, there were several solutions on the market at that time. The thing is that we chose a way of building what we call disposable products at that time. So the idea was that we go with immutable infrastructure, so we can literally build and destroy every day. We chose containers over instances at that time, so we considered using Packer and just packing all the applications into instances and just deploying them. Docker was, well, it was like 2014. Docker was relatively new to the market. It was quite a risky choice at that time. And we were considering microservices as an approach, again, to make it disposable in a way that we can like build a piece, experiment, throw it away, replace with a different piece of technology. So we wanted to experiment fast, safe. We wanted to make mistakes and not be worried about making them and, like, you know, being on call and like, well, crash in production from time to time. And the goal at that time, it was not that clear, to be honest, the last one, but that was decided on the way that one of the main efforts we're going to do about going into microservices was to improve observability and monitoring and how we see the whole infrastructure and products together as one big ecosystem. Pizzas are here.
That's possible talk.
So we built our very first microservice in early 2015. That was, what, 4 years ago. It was like REST API only service, no event model, just pure HTTP. It was covered by monitoring that was Graphite at that time, I think, and probably with Grafana. It was plugged into this big monolithic product. Well, as a like, let's play with this and let's see how it works. And it was deployed traditionally, meaning that there were no containers. So it was deployed as a literally like uploading of artifact to some remote set of servers, unpacking and just making it work. Although it was automated and it was in PHP. And we went for Swarm. That was still 2015. There was no what we call Swarm mode at that time. There was Swarm Kit or Swarm, or now it's called Swarm, Legacy Swarm, whatever. So it was a set of containers quite close to what Kubernetes offers at that time, because it was just like a additional layer on top of Docker offering you some orchestration. So it offered service discovery of some kind, so you could access services within, although you had to build, well, some HTTP layer on top of that, which listened to like Docker events and allowed you to access services. That wasn't working, so in Swarm mode, in current Swarm, there is mesh routing, which allows you to easily access microservices. Again, at this time of legacy Swarm, it was not that easy to do. Well, we run actually what's called Docker for AWS. So it allows us to easily implement EFS and store some shared data in NFS implementation from Amazon. And so orchestration with Compose is quite easy, especially when you can utilize the same format of files for both local development and well, production generally. Again, at that time it wasn't there, but it is now. These are configs and secrets. It's not like full, obviously, secret management, but it's at least a storage you can use to store your data. Well, but there were quite a lot of missing bits. So first of all, there was no job runner. Running one of jobs in Swarm was a pain. It was literally like impossible. There was no scheduler as a cron schedule, not orchestrator. So you couldn't like schedule some containers or set of containers to run as well you'd like to. There was no, and there is no auto scaling to the moment. So if you want to scale your instances and your services, you have to code something around this. There is no access control. Probably there is quite a lot of talk around like Istio or something similar, but again, there is nothing like this in Swarm to the moment. And again, there is no request tracing, so when some packet enters your microservice infrastructure, it's, well, sometimes it becomes quite challenging to understand what's happening if you have tens or hundreds of services talking together, you know. So how did we do and address all of these things? Well, with Docker API, that's the answer, to be honest. So, for example, this shows just on a principle level how we addressed jobs. So you get a Docker client, then you deploy your stack, and then you just poll status of all tasks running and all services running, and you can just get status of them and, well, make sure they're finished. Something like this. Or that's how we address scheduler. So we just say that, you know, we need this task to be executed every 10 minutes. Then that's the most challenging bit actually. Then we set a lock across the cluster to make sure that several copies of a container, well, don't schedule the same job at the same time. And then we just execute it. Execute in this case means actually, going to previous slide, it means that we just schedule some Docker stack into Swarm cluster and make sure it's up and running and it finishes at some point successfully. Solving auto-scaling, it is easy and it is not. The thing is that Docker for AWS allows you to synchronize process of adding nodes into auto-scaling group in Amazon and adding and removing nodes from your Swarm cluster, meaning that when you add just a new node or when you scale your group in Amazon, Docker for AWS automatically adds you one node in Swarm cluster and the other way around. So that part is solved for us with Docker. So there is generally a container running, just monitoring all this stuff and utilizing SQS and DynamoDB to do this. But what we need auto-scaling. So for that, we can monitor resources available on every node. For that, again, we use Docker API, so we can pull available resources, CPU, block devices, and memory from nodes, understand our limits, and if we are like somewhere close to limits on some percentage of nodes, so we understand that we might not be able to schedule a new service, then we can just add number of nodes we require to the cluster. With services auto-scaling, it is a bit more challenging because we have to define operational metrics like number of messages in like stacking queues. So based on that, we can understand that we need more power to and add more services and more replicas of our services. And from that, we actually can then see that we can add that many because we have that number of resources. And then our workers also scaling will trigger and add more nodes to the cluster. That's how we can shrink it both ways again. So then there is another thing, which is access control. Well, there is approach like I generally prefer to use, where we can define EM-like model utilizing like generally ready-to-go libraries where we can just set a list of resources, users, and policies around them. Then we can treat our services as users, meaning that we have to just give job token to every service, and then we can inject them via like Docker secrets, for example. For our customers who work with our services, we can say that, okay, we're going to use SAML, for example, and then we can have a single sign-on service to authenticate them. We can use two-factor if we want to, not for microservices, obviously, but for customers. And then we just need to implement some kind of regular token audit, so these tokens are refreshed regularly and, well, expire and whatever. And we need to create some kind of SDK to, well, to boilerplate our new microservices easily. But the thing is that for SDK there is a tricky part, because we don't really want our microservices to access this microservice on every call, because that's obviously going to be very expensive network. So there is probably should be some kind of a module which you can easily plug into your microservices, which will cache some access policies for other services to allow to reduce this time. Well, for that we have what we call Goblin, which is a microservice framework where we address quite a few things for microservice infrastructure, like managing different modules and runtime of a product, managing configs when our microservice runs in different environments, storage and cache where we want to access different databases, transport for both HTTP servers, clients, and WebSockets, how we monitor them. Well, in our case, we actually push metrics to Influx. How we log. In logging, the tricky part is, well, I'm going to talk about this in a minute. So ideally, we want to trace everything. And when we trace everything, the key part to have it unified across all your services is to have your trace ID or your span ID in literally every log message, which allows you easily jump from a log message to a trace and the other way around. That's a key part, and it has to come through all your code, so you can pass this information in every log message you invoke, well, has this data, meaning that you can't really just say in Go, logrules.info, whatever. You have to write your own logger and pass it through context. We use health checks quite a lot. They're not really explained, I think, properly, but this is a very vital thing in Docker to use. So Docker just says that, you can just run a shell script and, well, your container will be dead if it's not executed correctly. The thing about health checks is that there should be some application within application which actually can assess that your microservice is alive and well and everything is fine with it. And defining this criteria of a microservice to be alive is a tricky one, because it depends per microservice, but again, it can be unified for a set of them. You can check that, well, simple thing, you can just create an endpoint in your web server and just ping it and see that it's fine, which is actually an example in Docker documentation, I think. But in more complicated things, like when you access file system or where you depend on message buses, for example, that's not that straightforward to check whether your service is available or not. And tracing itself, well, these were actually health checks. So visualization of health checks, so that's how you can see them if they fail. So if you push them to Grafana if you push them to any time series database as metrics, then you can easily add them to a dashboard and visualize them that at that time that health check failed. And that's then easy to monitor across all your infrastructure to see that, in this microservice that health check failed because of that. And well, tracing allows you to easily then see how customer query travels across your microservices. So it can be from incoming HTTP request then to HTTP client to another microservice, doing SQL queries to databases, doing queries to NoSQL databases, doing, well, pulling some information from message buses or sending events. Or it can be, well, we have quite a tricky thing done, which is tracing emails. Like when we send an email, we embed trace ID into headers of an email. It goes, well, to a customer, but when a webhook on email, for example, email opened, invokes, it reports it back to us with that trace ID, so we can actually see delivery notification of emails in trace from customer requesting that email. Well, and there is quite a lot of stuff you have to build if you run probably anything. It's not just Swarm, so deployment of a cluster itself. So in a Swarm world, that's going to be traffic most likely. Then you have CI, then you have monitoring database in Flux. In our case, you have logging and tracing, which is Jagger. And you may or may not have some kind of GitOps running where you have state repos where you store state of your microservices, because if you have like tens of them and your cluster for some reason fails without a backup, then you need to restore the whole system somehow, knowing that these services were deployed in those versions, for example. And then there is a question of secret management, because even Docker, the Docker allows you to inject secrets into containers. You still need to have something like Vault or custom solution to allow secret rotation and general notification of your services that new secrets arrive, something like that. Then, well, when we started doing microservices, we didn't utilize any kind of messaging except for SQS. And there was an interesting thing that we wanted to do broadcasting of changes to services, like when something changes in one container, we want to broadcast to all containers of that service that there is a change happened and you need to do some preload. So this was done using Docker API as well. So there is a separate microservice which generally can pull from Docker API all the containers running for that service and just push some information to just those containers of that service. Then change audit in infrastructure, what was changing and when. If you run GitOps properly, then it's probably not an issue, but when you apply it to the data, so if you run any configuration databases, and if you store anything in SQL or NoSQL, then there is a question, how do you trace all the changes made to those databases? And how do you do email delivery, but it's not strictly related to the platform? And, well, monitoring. In our case, that's Influx, Grafana, Slack, and quite a lot of different TV dashboards running both Grafana dashboards and just custom software. Well, that's it. Thanks. Questions, please.
Come on, you can wait for a minute. Give him a
Yeah.
round of applause.
Thank you.
Question. Hello? Yeah, question? Let's start in the front.
Hi, if you made the decision whether to swarm or not in this year, would you still go for swarm? Or would you consider something else?
We ran legacy swap rollback. At that time, ECS was because they had this ECS agent container running every. It was crashing for us, I don't know, like twice, 3 times a day per node, and that was like, no, thank you. After that, well, obviously, when you choose the technology, you have to invest into making it work. After we chose Swarm, we invested quite a lot into making it work, and it was fine for us. I understand that maybe at this time ECS is maybe not that bad like it was 3 years, 4 years ago when it just launched. But, well, that's what it is. Thanks.
Right. So, think. Frequency. Another question? I'll go for back first. Sorry. Did I get very... So professional, right? Talk mostly about myself.
It's better, actually.
Test. It's fine.
Thanks for the presentation. One of the questions I have is, a lot of these containers are deployed for interacting with clients or external users that are up on the desktop and things like that. In terms of metrics, are there, I haven't seen any that from your presentation, but are there ways of monitoring the responsiveness of the from a client perspective to be able to maintain a level of, client happiness? This is especially with interactions on the desktops or clients from the internet, let's say.
Interaction to what?
For example, people are accessing the services through Chrome or something. There seems to be no metrics available to monitor that or to alert that there's issues, because it could be, the processes could be halted because of a slow SQL query or a slow MongoDB query or something. How do applications improve if there are no metrics, right? So are you aware of any effort in that space to measure responsiveness from a user or client experience perspective?
You can just quite relatively easily to measure response times on browsers of clients and just send this back, and in the background your clients will never, or probably GDPR, they should know that you can collect this data and just send it back to you.
But it would be nice if those agents or collection facilities are out of the box rather than somebody having to spend time to build.
I think there are.
Dozens of options in the market.
Yeah, there should be like tons of them, but probably people who build software on scale, they implement their own solutions because it's just easier for them if they have the whole monitoring system set up. It's relatively easy to implement.
Thank you.
I don't... Okay. All the way to the back. I'm sorry about the microphone stuff. It's,
Back here. Just curious about the Goblin application. I think is that a proprietary in-house application that you've built yourself, or is it something that you've?
It is proprietary for now, at least. Yep. What do you use console for?
Oh yeah, it's most of the stuff that you've just mentioned over there. So key values of being able to then have configuration deployed to multiple services and so on. Yeah.
In our case, we wrote our own key value storage, but it's backed. So basically, key value storage itself is a microservice which is backed by generally open source, like a distributed open source solution. Because writing storage system for key value these days, it's uneconomical. What? We have a microservice which is a front end generally for a storage system.
So this is good. Well, thank you. Thanks very much.
I think it's a good idea just if you have any other questions,
Just ask me.